last one, but I think it's a perfect fit because what I have to present is possibly sitting on top of what we have just heard. So, yeah, it's good to be back. It's the third presentation in a row about this project, Eclipse Automotive API Framework. So today I have some new features, and I would like to introduce to this blueprint project that we have done, just to show that this project also reaches out to other open source activities and what you can basically do with it. This slide, I will not present it in all detail, is more for you as a reference. So there were multiple presentations on this project already. If you're interested in the concept ideas behind, you can, for example, check the Community Days recording from Rotterdam. You can for sure visit our contributions. Today we have two of them. It's a small tool, convenient tool for the editing of the VSS catalog. This was originally contributed by ZF Group. And we have the application framework, an original contribution by Vector Informatik. So that's what we have. We started this project earlier, then we brought it to Eclipse SDV. This is why we started with actually a version 0.6. And after that, a detailed presentation of the workflow, a demo with all the steps in detail can be seen here in the contribution to Community Days in Gifhorn, or for example, this issue of the webinar Shifting Gears with SDV. Now, today, I would like to present a blueprint which is based on the version 0.7 release candidate and, exactly, some variations. I won't go into detail for the project itself, but to give you a short summary of what the application framework, which is at the core of this project, is all about. So in a nutshell, it's about application development for HPC, and it's about a tool and a thin abstraction layer that helps application developers in this domain to become more productive. So as written here, you can think of it as a thin abstraction layer in the microprocessor stack that sits on top of middleware solutions, be it AUTOSAR, be it AUTOSAR adaptive-based solutions, be it DDS, or be it, for example, solutions for testing like SILKit. The whole solution is text-based, so we tried to make it ready for CI/CD, for also agentic use, and we have also done prototypes in this regard, and it works quite well. Another important aspect I would like to mention, so there's a lot of talk about applications. For me, it's important to state what an application in the context of this project really means. So an application can consist of multiple executables that together fulfill a certain task. And the architecture the framework proposes is modular. That means each of those executables can consist of multiple modules, the so-called application modules. You see them here. Those modules are, first of all, independent of the lower layer, so you can develop them in a standalone project. You can even start testing on this level. So this is the domain of the application developer, and through the framework you get enabled to connect the app modules during design and compile time, basically, with different lower layers. So during testing, for example, it can be the SILKit, another open source solution that might help to speed up your system level testing. Later down the road, you want to migrate to a production middleware, whatever it is. The framework supports you with it, and in the end, the app module level code does not to be touched. VSS and also this tool we have as part of the project is one of the input formats that we support. So you can think of the signal definitions from VSS as a potential way to define the data that is exchanged between the application modules in here, but it's not limited to VSS. So a new contribution that we have in this published version is support for the IFAX format. Here, some of the key characteristics. So the API for the application modules is identical no matter if you communicate horizontally or vertically. Then we have the control modules, one per executable. They take care of all those boilerplate code you have in each and every project. So when it comes to execution of modules or your aspects, it also covers logging, error handling, etc. Exactly. Then we have per supported lower layer, the so-called middleware abstraction modules. In the open source project here, you find as one example the Silkit abstraction. This is particularly where we want to reach out for new contributions in the future. Exactly. Then the whole thing is modularized. The names here imply it. It's working at compile time, exactly, and it allows fast prototyping, still keeping open a door through production systems. When it comes to the API, so it's 4 parts that we have in mind, because it's also, in my opinion, that we have 4 essential pillars when it comes to the realization of distributed applications in automotive. We have for sure communication. That's at the core of every distributed system. Here we have done an abstraction, so we have data elements, abstracting in some IP the events, in DDS the topics. So it's for data-centric communication, let's say, realized by getters and setters, and you have event-driven support. Then on top, operations for remote procedure calls. You find it in some IP with the methods, but you also find it, for example, in gRPC. That's the second communication building block, and we use the term interfaces to group any combination of data elements and operations for the communication between the application modules. On top, persistency based on key value storage. So also here, abstraction makes sense. In open source, we see a lot of solutions for it. So for example, LevelDB is one option to name here. Then for sure, diagnostics is an essential pillar. Here, we think to support selected use cases. So the domain of diagnostics is huge, and there are plenty of use cases in this domain. Once again, reusing the basic principle of the data elements. And last but not least, the control API part. In the previous illustration, this can be mapped to the control module. So main function, interaction with the operating system, all the boilerplate we see in each and every project, written and maintained once again. What do we have today? What is planned? So we started with communication. Soon afterwards, we added persistency. The control part is a building block from the beginning. Diagnostics, here we have started with conceptual work, but this is planned for future releases. That's the part for the introduction. Now let me continue with the blueprint project. So the idea here was to take a scenario. The colleagues from ZF Group provided one, a simple application for a speed hazard detection. And the idea was to illustrate the building blocks of the project, how they interact with each other, and to use this once again as kind of a demonstrator for this Eclipse SDV project. It's already part of our GitHub project, so you can test it out yourself, and you can maybe use it as a blueprint for your project or as a starting point, or just look at it, check the code, and figure out if this is a solution that might help you in your daily work. So let me shortly introduce the scenario. It's really simple. So we have two parts. We have a vehicle speed calculation, which consumes inputs from the vehicle side. Mainly it's the pre-computed speed from the different wheels. Then we have some pre-computed information that is forwarded alongside with more data from the vehicle network side to the speed hazard detection part. And here we have a simple computation logic that signals the hazard lights in case some limit was detected. So that's it. Now let's start with the project. So I will switch now a bit between slides and the actual code base to show you also some of the artifacts. It's not a full live demo. The time is too short for that. But if you're interested in such a full-blown and step-by-step tutorial, you can check the first slide I presented today. You will find presentations on YouTube. So the starting point, not surprising, is the vehicle signal specification. So we have the public catalog from the Covisa project, and from there, most of the signals can already be taken. Now, this VSS tool was used to add custom signals on top. So something that might be applicable for other OEMs or tier ones as well. So if you have a custom signal you don't find in the catalog, you add it, you export the catalog in JSON as you have done, as you would then consume it in the next steps. So let's shortly have a look. How does this... So I have the files here. So this is the VSS style in JSON that you might be familiar with already. And on top, a new feature in this version 0.7 is IFAC support. Here, IFAC is YAML-based. For sure, it's only a simple use case for IFAC, which supports much more. But this is just to demonstrate that this input file is possible in different formats. Then next is starting with the application framework, which consumes this JSON file or the YAML file in IFAC format as an input. So we import those definitions and we create a so-called interface project, and we combine the different signals and the related data types to interfaces. So in this case, we have signals. They map perfectly to the data elements I have just introduced. And you see here we have 4 interfaces, and they group, as illustrated, a set of data elements. This is done in config as code, as we term it in Python. So it's all text-based, and it's really simple to define such an interface. You give it a name, you define a namespace, and then one by one you can add the data elements. And here on the right-hand side, you just iterate over the signal tree guided by IntelliSense. So you select your signals from the catalog, basically. And here illustrated for the speed calculation interface, it's the drive direction and the vehicle speed. Next is application development. So we create in a separate project type the application module. So we have the vehicle speed calculation module and we have the speed hazard detection module. And we import the just defined interfaces from the interface project. And now, in the same style, config as code in Python, we do a definition of the app module details. So we define what is this module supposed to consume, what is it's supposed to provide. Do we maybe have periodic tasks for periodic execution? So same style, you introduce a new module, you give it a name and a namespace, and then you add the consumed and provided interfaces. Here the speedIF consumer, and here you just select it from the imported interface project. And then also, as provided by the colleagues from ZF Group, the implementation work can start. The framework provides you with a ready-to-start project. So let's switch here. We have the vehicle speed calculation project. You see here, this is the snapshot I just presented. You start with modeling. You click here. By the way, we also have this nice VS Code extension, which keeps you from learning all the command line commands by heart. So you can just generate your application module project. It creates the complete project with implementation stubs and interface definitions for you. And on this level, you can already do a first level of testing, which is my next point, unit testing. So each of these modules can be considered as a building block of the application. And you want to start on this level already to ensure the functionality. Here we base on Google Test, and the framework produces and generates for you the interface mocks. It provides you also with test stubs, and that allows you to use the interface project also for some testing already. So you get a test stub, you fill your test code here. Let me show this here. So you already click on build. So here in this implementation folder, you get header and source file stubs to fill your implementation in. And in this unit test folder, you find the test stubs. Here I added a simple test case, which uses the mocks to set the values and checks for a calculated speed on the other side. So vehicle speed. You get the unit test, you execute it, and this is the place where you just can add your own cases on top. Then the last step and the third type of project is integration on executable level. This is then where you define one or multiple executables. You define a base period for it, for the control module basically. You add instances of the previously created application modules to it, and you do the wiring. That means at design time, you connect same style config as code in Python. You connect your application module instances among each other. So here, one example. One instance of the speed calculation application module, and here with this small snippet I connect the speed hazard detection to the speed calculation IF. Now, on this level you want also do some testing, and there are multiple levels, and here the framework is a perfect helper because it allows you to have different variants just by changing config as code and by regenerating the project. So let's start with the simplest case. We have only one executable. We have all the modules added there, and we add on top a so-called test module that allows to execute this as a process in your Linux system, basically, as a starting point, and you can do some testing. The test logic would then live in an added test module here. Let's switch to the project once again. So here in this integration project, you do the modeling. And you see here, we start with the executable. We add the application modules, and on top our test module. And down here we have the wiring part. same procedure here, generate a project. This time, so on this level, no own implementation is needed. Can directly click install, which includes the build step. You can also, on integration level, use this visualization feature to keep an overview. What modules do you have? How do they relate to each other? So for example, here we see that the test module connects to the open ends that we have seen earlier. So it is, for example, then acting as a provider for the speed information that is supposed to come from the vehicle network side. So that allows and enables the application developer of this speed hazard detection already without input from anyone else to do tests, to think of test cases, etc. Now, so I have also added some implementation parts for that, such that this whole application actually does something. So we have already installed it. Integration project. So here it's created, the demo executable. And we see the controller base, so this is the control module, starts up the modules, it connects them, so it creates the objects, it connects them, and we see here the speed hazard logic that I've added is checking for the values, and the test module implements kind of a start and stop functionality, so we increase the speed up to 50 kilometers and the speed hazard is detected at 40 kilometers. Just a random test case to demonstrate that it actually functions. So this is system level on system level testing in a first step. Then second step would be to separate the application modules and put them to different executables. So like illustrated here, demo executable now only holds the speed calculation and the hazard detection, and the test module is separated. This now brings in the need for a communication middleware, and the framework already brings support for SILKit, which allows you to do this inter-process communication then. And for serialization, we use protobuf, and for protocol and transport, SILKit. Now, the cool thing actually is there's not much you have to do to switch from level 1 to level 2. I have copied the integration project configuration, and now I have to modify only some parts in the wiring aspect down here, which is instead of connecting the modules directly, I connect them to SILKit, and I provide a common instance such that they can find, similar as the topics in DDS, that they can find them during runtime. Now, I can just here change one line to switch from one config to the other. I regenerate the project. So all done. So it's already in the build cache, so this should be fast. And now we have two processes, which makes also this SILKit registry necessary. So I start this kind of a broker or daemon, if you want, from SILKit to the background. And I start the demo executable. And I also have another folder for the test executable, and we see in the beginning no test executable was there. The vehicle was in standstill. Now we started. We see the test case executes as before. And the same in reverse order. Yeah. So that done brings me to the last part. Now you have done the testing, and for sure you want to contribute to a vehicle project. That means you want to go to a production middleware. And here we thought, well, let's have a look into S-Core. They also have the communication as a central part. So that would mean you would now migrate the system here to, for example, one that is using some IP protocol to communicate with a vehicle network. And ECUs from there would provide the velocity information and all you need for the application here to properly function. So we did that. We created this platform abstraction module for S-Core communication. And yeah, the outcome is as follows. So we did this already end of last year. Maybe that was too early, at least this is my conclusion. So we did this even before the version 0.5. We found some mismatch when it comes to the build environment. So S-Core is using Bazel. The application framework projects are CMake based. We also found back then, I think this has changed in the meanwhile, fixed tool chains. Long story short, we created forks of the projects. We added CMake support to have it in one environment, and we also contributed that. But yeah, I can really understand that those two pull requests got rejected because no project is really interested in maintaining multiple build environments. Nevertheless, we have completed this prototyping work, and no surprise, it works. So this IPC connection between speed calculation and hazard detection can be mapped to S-Core communication, alias LOLA. But as already triggered, the conclusion on our side was that we will have to come back to this topic later. We will wait for upcoming releases, and we will internally also discuss how to continue with the build environment and discuss if maybe Bazel is an option for us. This brings me to my last slide. So what's ahead for this project? So today, the version you find in the repository is in a monolithic form. That means all building blocks are bundled as one Python package. Here we are working on a modularization that would make it really easy for contributors in the future to bring platform support for S-Core, for ICE Oryx, or for DDS, whatever you have in mind. We will take up this topic with S-Core communication again to demonstrate that it perfectly functions also here as a potential lower layer. And as mentioned in one of my slides, we plan to extend the use cases and API parts for diagnostics. And that's it. Thank you very much for your attention, and have a nice evening. Yeah.
Thank you. Thank you, Manuel. So, is there any question? Yes, Michel has a question. Thank you, Olga.
Thanks, Manuel. That looks very interesting. I would have the question, what we saw before in the tool, is this part of the open source project, or is this something where you use artifacts from the open source project?
Which tool are you referring to?
The one that you showed next to the presentation when you showed all of the examples.
Yeah, so, well, are you talking about the extension to VS Code or the samples?
It was a simple VS Code extension, which is also
yes,
part
exactly.
of the project.
So the extension source code is not part of the project, but the main motivation for that was that we had to publish it to the Microsoft Store to make it available. That's why it's available for public. It's in the Microsoft Store, and you can just add it to your VS Code. Once we have clarified how this can be part of the project and in the Microsoft Store, we will for sure do so, but that was the motivation. We wanted to have it out. And
So it's no proprietary thing, so we could basically use it, give feedback.
you'll find it, exactly.
Okay,
Yeah.
thanks a lot.
Yeah, welcome.
Okay, maybe we have time for one more question. Okay. So, is there a question? No. Okay, so otherwise, one
fine.
question could be, are you going to write an SDV blueprint proposal? Because I don't think it's there yet, so
Well,
we are...
yeah, but as far as I understood, the blueprints in SDV or in Eclipse SDV should at least cover more than one project. So here the focus was, so I reused the name blueprint, that's for sure. But I think once we extend, for example, to S-Core communication, it's a perfect fit also for this bigger scope. Yeah?
Okay, perfect. Sounds good.
Yeah.
Thank you so much again.
Welcome.